right now. What I'm going to do though is we're going to actually talk about a couple of different methods and a couple of different techniques that we can use when we are sketching parabolas in general form. Basically, each key point that we need to find, we can often find in different ways. Sometimes a particular method is more efficient than another method. So you just got to work out which is going to be more efficient. How do you find out which is more efficient? You do lots of problem questions, you do lots of examples, and you get better at picking it yourself when you need to. So this is the example that we're going to do, and then I'm going to leave you with a couple of examples to go on as well. So first thing, we're sketching in general form. General form is when it's expanded, and we've got something in front of the x squared, something in front of the x, and something in front of the c. It is possible that you might be missing one of these terms, but the general process is the same. And if it helps you, if for example there was no constant at the end, you could just write plus 0 if it helps you understand what's going on. But the key points that we have to be able to find are the y-intercept, the x-intercepts, and the vertex or the turning point. So let's work through this. First step, if I want to find the y-intercept, I've got two methods that I can do to find the y-intercept. Is that big enough or is that too small? No. That's okay? Okay, the first method for finding the y-intercept is really, really easy. When we are in general form, the y-intercept is always the c value. So I can actually just write the y-intercept equals 8. And I can put that as a coordinate, x is 0, y is 8. So if I'm in general form, don't expect you to do any working out. But if you're in a test and you're having that mental blank and you have that moment, I'm not quite sure what's going on here, my other technique for finding the y-intercept is to do what? I substitute in, so the y-intercept sub in x equals 0. When I do that, I get 0 squared plus 6 times 0 plus 8. And you end up with the exact same answer, except you've reminded yourself that when x is 0, y is 8. And we get the coordinate 0, 8. Which method would you choose? This one, why? This just takes so much less time. It is quicker, it is more efficient. I would expect you to do this. Okay, the second thing that we have to find is the x-axis intercept. So again, I've got two methods for finding the x-axis intercept. Both of them involve this first step where we substitute y equals 0. This is the same as we did with all of our linear graphs. The x-axis intercept occurs when y equals 0. So when I substitute that in, I create this as my equation. And now I've got an equation that needs to be solved. I've got null over here. Can I use the null factor law to solve this? What's the null factor law?
Null factor law is when stuff equals 0. So it has to equal 0. And then you do the thing with 0 in it.
When it has to equal 0 and you do the thing with 0 in it. I'm going to expand on that a little bit more. We've got null. When we get the factors over on this side, we can then use the null factor law. So we factorise. Easiest way to factorise this one, it's not a highest common factor, it's not a DOPS, it's not a perfect square trinomial, it is a monic quadratic trinomial. So I want two numbers that multiply to give 8 and the same two numbers add to give 6. Do they exist?
Yep.
What are they? 4 and 2. So it becomes x plus 4, x plus 2. And I'm tired of that whiteboard marker. It's squeaky and dull. Okay, so if that equals 0, then either x plus 4 equals 0. So now we solve in parts, in which case x has to equal what? Negative 4. Or x plus 2 equals 0, in which case x equals negative 2. So that's method 1. Method 2, I can use a quadratic formula. The first step is still the same. The x-intercept, I need to sub in y equals 0. Now that I've got my 0, I can use the quadratic formula. What's the quadratic formula?
Negative b plus or minus square root of b squared minus 4 times a times c over 2a.
Negative b plus or minus the square root of b squared minus 4ac over 2a, and that's possibly the weirdest b I've ever seen, but we'll deal with it. Okay, so what is my a? My a is 1, my b is 6, and my c is 8. So it is x equals negative 6 plus or minus the square root of 6 squared minus 4 times 1 times 8, all divided by 2 times 1. So now I've got to get my math brain on and do this as quickly as I can because I'm pretending I'm in an exam and it's also making the video shorter. 36 minus 32 is 4. 2 times 1 is 2. Square root of 4 is 2. So it's 6 plus or minus 2 divided by 2. And then now I just have to work it out for the 2 individual parts. I'll do that over here. I'll keep my method 1 and method 2 going on. All right, so it would be x is equal to 6 plus 2 over 2, which is 8 divided by 2 is 4, or x equals 6 minus 2 over 2, which equals 1, doesn't it? No, it doesn't. 2. Why did I get a plus in one of them and a minus in the others? No, it should not be that way. Oh, because it's negative 6. I missed the negative. Negative 6 minus 2 is negative 4 divided by 2 is negative 2. And negative 6 minus 2 is negative 8 divided by 2 is negative 4. There you go. Made a mistake. Did we end up with the same answers? Yes. Which method would you choose? Null factor law, quadratic formula? I'd probably use the null factor law in this case because it was quick to factorise. Will this always work? Yes. Are you likely to make a mistake? Yes, I did. I just proved that you're likely to make a mistake because there's a little bit more, few extra ways that I could make a mistake. Okay. Now, this test is no calculator, that is correct. To end of next week, no, end of the week after next. All right? Yes. Last thing we have to be able to find is our vertex or our turning point. We have, again, 2 methods. So, the first method that I'm going to use is completing the square. And we saw yesterday how we could use completing the square to change into turning point form. So if we start with the equation x squared plus 6x plus 8, then to complete the square we're going to keep the x squared plus 6x, then we're going to add 6 divided by 2 squared, subtract it again, 6 divided by 2 squared, plus 8. The first 3 terms are always a perfect square. And it will always give me x, whatever that is, plus 3 squared. I know I'm going quick. We can watch the video again and you can ask questions later. I'm getting a little bit distracted by a couple of people. So the first 3 terms will always be a perfect square. Whatever is inside that bracket ends up here. So 6 divided by 2 is 3. That's where I got the plus 3 from. Over here, minus. This is 3 squared, which is? 9. So it's minus 9 plus 8. What's minus 9 plus 8? Minus 1. And going through that first part of completing the square, we have converted our equation from general form into turning point form. What does this plus 3 do to my graph? There's a word I'm looking for, starts with T. Translates. Where's it translated?
Left 3 places.
3 places left, parallel to the x-axis. So it's translate 3 places left. And what's the minus 1 do?
Translates it down 1.
Translates down 1. So now I know it went 3 places left, so it went to minus 3, and 1 place down, minus 1. I've got my turning point. The second method for doing that is I can actually just use symmetry. And to use symmetry, I have to actually think a little bit about what these 2 points were. These were my x-axes, weren't they? Right, so my x-axis intercepts are at -2 and -4. So I've got an x-axis intercept at -2 and -4. Because these are parabolas, and I spoke yesterday about parabolas are always symmetrical. If I know they're my 2 x-axis intercepts, my graph's going to look something like this, isn't it? So the turning point would have to be exactly halfway between those 2 x-axis intercepts, wouldn't it? All right, so what's exactly halfway between -2 and -4? So we know that the x value of the turning point, because of symmetry, is -3. How do I find the y value when I know the x value?
Have to go down 1 across 1 until you get to a point, the same point.
You could, but that's limited and you're going to make a mistake. What's this rule tell me? This rule tells me what y is equal to when I know what x is. That's exactly what this rule does. It tells me what y is equal to. Do we know what x is?
Yep.
Cool. So we're going to now sub in x equals -3. I get y equals -3 squared plus 6 times -3 plus 8, which is 9 minus 18 plus 8, which is equal to -1. And we've found the y value for the turning point as well. So, which method would you choose? Completing the square or symmetry? For this question, which one would you use? I probably would have used symmetry because these are nice, easy numbers to find the middle of, and it's not too hard to substitute in x equals -3. When I start getting fractions and surds and all sorts of weird stuff, sometimes the completing the square method's easier. What are the 3 points you have to put on a graph? 3 key features.
Turning point,
Turning point,
x-intercept, y-intercept.
x-intercepts, y-intercepts. Have we found those 3 key things? Yes. So the last thing I've got to do is sketch my graph. And because this is being filmed and you can get it later, I'm going to rub this out. And I'm just going to draw my sketch graph over here. Remember, sketch graphs, they don't have to have a scale, but they do have to look reasonable. They can't be trash. Use the grid lines to help you. In an exam, they will often give you grids. So, -1, -2, -3, -4. I'm going to say I've got a point here, I've got a point here. I've got the y-intercept at 8. I'm going to stick that there on 8. Now, there's 3 points that I have to join. One of the things that students will often do is they'll then say the vertex is down here, and when they're trying to join those points, their graphs kind of start to have like funky bits in it. That would lose a mark. That's not symmetrical enough. That's not parabolic shape. It should not turn out again like this. So, my recommendation, put your x-intercepts and your y-intercepts on. Use those points to make a nice flowing parabola shape. Okay, and then now mark everything with its coordinates. And I'll go over that. That should absolutely be the other way. Thank you, Noah. And there's my parabola. What I would like you to have a go at is, can you have a go at sketching these three graphs? I want you to do it in pairs. So when you're working in pairs, discuss which method you think you're going to use for each of those graphs. Okay? Have a go. I'm going to stop filming.